Good morning, everyone. Good morning. Hope all is well. Hope everyone is doing all right. Let's see. Yep, look like everybody's in here. So, um, let's see. What did I say we were doing today?
Asking questions.
Asking questions. I was wondering if I told you guys that.
Yeah.
Yeah. So, anybody have any? Anybody have anything they would like to see me do, or any questions that they got stuck on?
On percentages. I honestly didn't even attempt anything yet because I got the calculator, but
Okay.
I don't know how to use it. So I was gonna get with you and try to figure that out first before I did
Okay.
anything.
Yeah, it's not a problem. This is not the last day ever for for you have to ask questions. If you don't have them now, may not come until you actually get into certain assignments. May not come until after you have time over the weekend. But it's also like a buffer day wherein I'm not going to do anything new. You know what I mean? So it's not like you're getting hit with new material. You see what I'm saying? So it's not just for the questions, but it's also for kind of like a break. You know what I'm saying, from new material. Um, but yeah, so and yep, most definitely. Have you opened the calculator yet?
Well, I actually, uh, my daughter let me use hers.
Okay,
She had this one.
okay, cool. So
It's a T184 Ti 84,
okay, that's a good one. Yeah, that's a good one. Should do
but it's
everything
got
you
a
need.
whole. Yeah, it's got everything I need plus the stuff that I don't know how to do anything except for the 2 plus 2,
Hmm.
4 times 3.
So with so with that calculator though, that means that you can type in the problem just like that. You know what I mean? Using those
Awesome.
same buttons. So you would type in 4,000, use the parentheses, 1 plus 0.053, division, 4, close parentheses. Look for this button right here, because
I have
that's
a
available
question.
to you. And then parentheses 4 times 10, parentheses, close parentheses. You can type it in just like that and get the answer.
Even though we can type it in just like that, do we still need to show work for it?
No, it wouldn't be any work for you to show.
Okay.
What?
Mhm.
So
Because
Well,
you
what? So
said
what?
show work, and I'm like, we can just
yeah,
use our calculator for basically everything that we're doing right now.
yeah. So now, for some things, you wouldn't be able to, like when you're solving an equation. I expect to
Oh
see the
yeah.
steps. You see what I'm saying? It's just certain things that you will have to show work for to show that
Okay.
you actually did it, versus certain things like calculation stuff, like plugging into a formula. I wouldn't expect much work for that, especially when
Okay.
you're talking about raising something to the 40th power. You know what I mean? I wouldn't expect you to do that. But yeah, but certain things you would have to. So I would expect you to at least show me that the formula, you plugging it into the formula, that type of thing. Yeah.
Okay.
Yep. And then there are certain things I think initially we were doing order of operations. So since we were focusing on order of operations in that type of situation, I would expect to see steps. I think that was back in chapter 2 when we are actually focusing on order of operations. So in that section, I would expect you to show me steps there because that was the main focus. Other than that, we were just shooting the breeze. So yeah, so it just depends on what the focus is too. Um, you know. Could you review a question regarding longer, shorter strings? Do you remember what number that was in the review? I can find it, or if you already
Let's
have one.
see, it was in the review test number one. Oh
Hmm.
gosh, I got to give you a number. I printed out the example.
Oh well, do
Okay,
you just do you just want to read that to me?
sure. It says
Okay.
25-piece string cut in two pieces so that the longer piece is 4 feet longer than twice the shorter piece. Find the lengths of both pieces.
Hmm.
So I took a good half hour trying to figure this out. So if you could cut down some of the time, that would be great.
Not a problem. So now you said it was a 25 piece. Did you mean 25 inch or
No, 25-foot piece string.
25 foot?
That's
Okay, I didn't hear the foot part.
yeah.
Okay, cool. All right, let's do it. So we have a 25-foot string, which we're gonna cut it into two pieces, longer piece, shorter piece. So we need an algebraic representation for each piece. So we know we have our two pieces. We're gonna have a longer piece, we're gonna have a shorter piece. Now, the shorter piece is described in terms of our, the longer piece is described in terms of the shorter piece. We have the longer piece is gonna be 4 feet longer than twice the shorter piece. So what we would do is call the shorter piece X, and then write that longer piece in terms of that X. So if you're talking about 4 feet longer, that would be +4. Then twice the shorter piece, that would be 2x. So we're looking at 4 plus 2x. All right. So anybody have any questions on what we've done up to this point?
Okay. So all of this is on the left-hand side of the equation?
Well, yes. Because now, if you look at this, if we want to look at a string and we're talking about cutting it into pieces, we got our shorter piece and our longer piece. This one is going to be X. This is going to be 4 plus 2x. And then all together, we know they add up to 25. So when we write the equation, it's going to be X plus 4 plus 2x, and they were going to equal to 25.
Okay.
All right. Everything okay so far?
So far.
Okay. So now those parentheses aren't necessary. I just use them just to break off or to group together what, piece came from what. This is my shorter piece, this is my longer piece. So I don't need them. Like I said, I was just doing it for display purposes. So we can go ahead and combine our like terms. X and 2x is 3x. Then we can subtract 4. The x is equal to 21.
4 from each side. Okay.
And then to solve for x, divide by 3. X is equal to 7.
Okay.
All right.
So the shorter piece is 7 feet, and the longer piece is 14.
All right. So now the longer piece has to add. Now don't forget both pieces have to add up to give you 25. So you can either subtract 7 from 25 or go back here and plug in 7. So whoa, that's 4 plus 14, which will give you 18. So either or, like I said, you could have subtracted 7 from the 25, which would have gave you the 18, or plug it back into what you called your longest piece, and then you'll still get that 18.
Okay.
All right.
Well, that certainly didn't take a half an hour, so that's good. I've got it now. I understand. Thank you so much.
Not a problem. All right. Anybody else? Anything else?
Yeah, I got a question.
Yes, sir.
So a -10 squared.
Now, is that with parentheses or without parentheses?
Is without parentheses.
All right.
And that's my question. All right, so explain the difference, please.
All right.
And why.
Okay. So when you use parentheses, when it comes to exponent, you're saying that everything in the parentheses needs to be affected by this exponent. When you do not use parentheses, only thing that is affected by is what's right up against it. So when you look at it without parentheses, -10 squared, what's being affected by the square is just the 10. So that's going to be, that negative is just going to sit on the outside, and then that's going to be 10 times 10, which is negative 100. But if you use parentheses, everything in the parentheses is going to be squared. So now that's negative 10 times negative 10, which is now positive 100. So that's the difference.
Oh, okay. Okay.
Okay, so the same thing is, if, let's say if I have xy squared versus parentheses, xy squared. So what this says, what this one says is that the y is being squared, but not x.
Okay.
What this one says is that x and y is being squared.
Okay. And in that example right there, the x would be the negative. I mean,
Yeah, exactly.
Okay.
Exactly.
All right.
Mhm.
Okay. All right. I got you. That makes a lot of sense now.
All right.
I'm gonna have some more questions too. So just skip to some other people, and then I'm gonna find some other stuff.
All right, not a problem. Anything
I'm
else? Anybody else?
I'm gonna be honest with you, man. I took that pre-test.
Mhm.
I haven't taken the one test yet,
Mhm.
and it kicked my butt, man. Like it really did. I sat on it for about an hour, maybe a little longer,
Mhm.
and just some things I knew, but some other things I didn't know, and it made me stay on that. Like it wouldn't let me go past it. And
Now the test wouldn't let. I mean, you couldn't move to the next problem, or you just saying that you were so focused on what you didn't know?
no, I couldn't move to the next problem. I mean, I don't know if it was just it was probably operator error,
Okay.
but I didn't know how to make it go to the next problem. And it kept making me redo a different problem.
Okay, I'm gonna check on that before we leave to make sure it's set properly.
And how many chances do we get to do the problems on the real test? Do we get more than one opportunity to?
Well, the test itself, like you get 2 chances to submit the whole test. So no, it is treated as if it is a test. So you do have to run through, you submit it 1 time. So it's not like the homework we get to do 3 times. So it is, treated like a test. Now, if you go through the test and you don't get the score that you like, then you can do the test over. But it is a little different format. It doesn't have the help tools. And then, yeah, once you submit it, that is it for that score. Yeah. It has to, you got to up the ante a little bit in comparison to the homework,
Yeah, but I mean, you got like I ain't been in math in 20 some years, man. I ain't trying. I've learned more in this 3 weeks or whatever than I remember learning in my whole high school career. So
Wow.
I mean, this is a lot, man. And I'm going through. I mean, I'm going through 30, 40 different pages of math notes and scratch papers and
wow.
So
I just got
anyway.
out of high school, but you're teaching it way better than any of my teachers taught it. Like,
wow.
Yeah,
for real.
100%.
Well, I appreciate
100%
that. Wow, I appreciate
agree.
that.
And so like I know the material, but it's coming back a lot quicker because of how you are explaining it.
Wow. Thank you. I appreciate it. It's always good to hear good stuff. I thank you. Thank you. I appreciate that.
Yes, sir. Most definitely.
Miss Wilhelmina says it's been 40 years. Woo. Well, kudos to you.
But it's coming together. I mean, it's coming together. So,
Wow.
I mean, but it's been a long time.
Wow. Wow. It's just crazy that all of the dynamics of people that are in one room,
Is there anybody else that's struggling, like has anybody else taken the pretest and like, was the struggle evidently real?
The struggle's real, honey. It's real.
I think I'm the only one.
No, not at all.
And I'm glad you said that. I think where a lot of people make a mistake when it comes to math is that they'll put themselves on this island of I'm the only one. I see all, I see all, you know what I mean? And don't ever go into a math class and feel like you're the only one struggling. I don't care how many questions people answer and stuff like that. That's not an indication that they're doing well, or that they're just breezing through. It might be an indication that they're doing well, but that doesn't mean that they're breezing through. They could be putting extra time in, or something like that, or getting extra help somewhere. But that doesn't mean that it's not a struggle and you're the only one. So never put yourself on I don't care what math class you take, never put yourself on the island. I've never had a situation where there's only one person that's having a tough time. It's never that case. So, but I do want to show you this though, real quick. Now I know you said you had troubles navigating in the test review. So these buttons up here helps you skip these arrows, and then right here, this button, you can go and actually pick the problem you want to go to.
See, all that's brand new. You just open up some new doors for me, right there.
So yeah, so you can skip all the way to the last problem if you want it and everything like that. So that should be the same way in your homework as well. Those two arrows up here, and then like I said, these three lines will help you just go to the next one.
All right. And I have another question. I'm not trying to hog up everybody else's time on this, but so is it possible for us for me to fail or do poor on the test and still pass the class?
It just depends on your definition of doing poor. Now, if you dropping 20s on them,
no. I got more of an understanding.
Yeah, I'm putting it into perspective for you. Because if you're dropping on real low scores, then it will be hard to pass the class. I think the lowest score is, so if you're trying to pass with at least a C, we're talking about at least that C. I think the lowest, let me see real quick, you can do, but now this is with you doing everything else. That means you're doing all of your other homeworks. Okay.
100%.
Let me see, times 0.7. You can really average a 60 as a test grade and still pass the class with a C if you do all your other homework.
All right. I'm not trying to do that. I'm just saying, man, it costs me a lot of money for this class. I don't want to have to pay again.
Right.
But I will if I have to.
Got you.
So our hope.
All right, Ms. Wilhelmina, you went out. If you're still talking, I don't hear anything. Yep, still don't hear anything if you are talking. So you might want to type it in the chat. Yeah. All right. So while I wait for her message, anybody have any other questions? I know Mr. Tucker, you said you had something else for me.
All right, so I want to do a problem.
Okay.
And I took a picture of a problem. This thing was, all right, so it's -13 plus -7 squared with the parentheses.
On the -7, like that?
Yes. Over 5 minus 14.
So all of that.
Yep.
Okay. Excuse me. So first thing we'll do is take care of the square. Talk about -7 times -7, which is positive 49. And now we can add this on top separately. Subtract those separately. Those two different numbers, top and bottom. So it's going to be 36, positive 36, and down bottom, -9. And now we can go ahead and divide that out. Positive 36 over -9, -4.
Thank you.
Not a problem. All right. What else we got? Anybody else? So I think right now what we have available to you guys, you got test 1 and test 2. Hold up, I'm in the Oh, yeah. I'm in the right shell. Okay, yep. So we got test 1 and test 2. Test 2 was chapter 10. So we're looking at
Can we do
Mhm.
some compound interest stuff real quick?
Yeah, do you have one in particular you want to see done?
No, I don't have one in particular. I got the formula notes from the lab, but I know that that's going to give me some problems. So I just wanted to see some extra stuff if you had any.
Let me pull it up. Somebody asked about test 2 or chapter 10's due date. Let's see what we're looking at. So we're done with chapter 10. Yep, I remember we did say we were going to talk about that today. 9/26. So you got due date of 9/19. That's chapter 2 and 3. Chapter 4 is 5 sections. I'll give you to October 3rd for chapter 10's content.
So test 2 is due October 3rd.
You said Tuesday? What was that?
I said so test 2 is due October 3rd.
Yeah, all of chapter 10's content will be due October 3rd. So I'll make that adjustment shortly. Yep, not a problem. All right, so let me get in here, find a compound interest.
And is the first step on any one of these problems, if there's decimals, to get rid of the decimals, and if there's fractions, to get rid of the fractions?
When you say any of these problems, what do you mean by that? You said
On any equation or
just in general, just to solve an equation.
right? Yes.
No, not necessarily. No. It just depends. You don't really have to get rid of decimals unless you just don't want to deal with decimals. It's not really imperative that you get rid of decimals. More so, people like to get rid of fractions. I would clear out the fraction by multiplying each numerator by the LCD. But decimals, most people are okay with decimals because they deal with money. You know what I mean? So you don't have to get rid of your decimals, really. All right. So here's one. We have a couple invest $4,400 in an account paying 10% compounded quarterly. How much is in the account after 1 year? All right. So let's go to the notes. I'm gonna write down the given pieces of information. Mr. Tucker, were you copying that down? Or you good? I can go to the notes. Or...
No. I'm good. I'm just gonna follow along with it.
Gotcha. I was making sure. I didn't know if I saw you writing or not. All right. So what you want to do is, we know we have the formula. That's our formula right there, compound interest formula. So we need values for P, R, N, and T. Once we're done calculating, that represents the future value or the value that will be in account after however many years.
So that's the unknown,
right?
In this. All right.
So we're gonna leave that be, but we need P, R, T, and N. So let me go back. So they invest 4,400. So that's our P at a rate of 10%, which is 0.1. When you convert it to a decimal. So you do need to convert that to a decimal before you do your calculation. Compounded quarterly. So if it's compounded quarterly, that means 4 times per year. And then it says how much is in the account after 1 year. So we only have a 1 right here. All right, everybody good so far? So plugging in the formula, that's 4,400 times 1 plus R, which is 0.1, over N, which is 4, raised to the, and make sure, like I said, if you're using something like the TI and you can put your parentheses, make sure you use the parentheses exactly the way that I'm using the parentheses, and you'll be all right. And so that's N times T, so that's 4 times 1. And of course, my son took my calculator upstairs. That's awesome. Okay. Hold on 1 second.
So can I ask a question real quick?
Yes, sir.
So if you didn't put the parentheses around the 4 and the 1, what's the difference? Like, yeah, if you didn't do that, what?
Now, so just like when we talked about parentheses before, what this means is that it's going to raise it to the 4th power, then multiply it by 1. You see what I mean? Here, when you put the parentheses there, I'm going to multiply these two together, and then the result will be your exponent.
So parentheses means
Because
do it first, get rid of the parentheses.
right. Now see, I wrote it, superscript, smaller, but the way the calculator will read it if you don't use parentheses is like this. So how you type it and how you thinking is different between, from what the calculator is actually reading. If you don't use parentheses, it's going to raise it to the 4th power and then multiply it by 1.
Okay, so the parentheses just groups it together in the calculator.
Exactly.
And tells us what to do inside first, like with the
And basically you're programming the calculator, you're telling the calculator what to do first. So when you use parentheses, you telling the calculator, hey, this whole thing is my exponent. Multiply it times 1 and then apply it as an exponent. And so that's why the parentheses are important. Same thing here. If I didn't have parentheses right there, I would just raise that to the exponent, but I wouldn't raise the plus 1. But the formula says you got to use plus 1, to that. Yep.
But can you just put in like 4? I mean, can you just put like 4?
Yes, in this case, but remember, I'm setting you up for all types of situations. You see what I mean?
Exactly.
So if this 1 was 5, you would do 4 times 5 and it would be 20. Then the 20 would be the exponent, right? Yep. So I'm just giving you the general template for what you would do for your calculator. Yeah, but yes, you most definitely, once you get the hang of it, you can do a whole bunch of stuff when it comes to math. You know what I mean? So yeah, but once you get the hang of it, you know what you're doing. If all you want to do is do 4 right here, because you already know 4 times 1 is 4, yeah, you good to go.
Okay.
All right. So let me go ahead and put this in the calculator so we can make sure we compare our answers. Some of you probably already have your answer already. So what I'm getting is 4,856.776. Well, 777 around that 6, but I just gave you that because just for note purposes. Remember, we're dealing with money, so you round that to 2 decimal places. All right, so just reiterating, reemphasizing that piece, it more than likely you will have a run on decimal, and more than likely they won't tell you to round to 2 decimal places because they assume we're dealing with money. You know what I mean? So if they may say it, they may not, but if they don't say it, they assume we're dealing with money, so they assume 2 decimal places. So just throwing that out there, we're dealing with cents. So can you hold on? Let me say this: when I say we're dealing with sense, not common sense, I'm talking about sense as in money. I don't want nobody to feel disrespected. Not we're dealing with sense as in money, not challenging anybody's common sense. So I know it sounded like that. Just want to make sure we're clear. Go ahead, sir.
Can you perform the part that's in parentheses? Can you like dumb that part down for me? Like the 1 plus 0.10 over 4. Can you perform that part in a visual?
So you have to do what's in the parentheses first. So like Miss Wilhelmina said, I would go ahead and multiply that 4 times 1. And then inside of this parentheses, I will go ahead and divide that out. So you're talking about
Just
4400. So it's 1 plus 0.1 divided by 4 should be a version of 0.25. Yep, 0.025. So that's 0.025. And then that's raised to the 4 times 1, which is 4th power. Then you're still in here. We can still simplify that. That's 4,400. That's 1.025 raised to the 4th power. So now the next move is to raise 1.025 to the 4th power. Now that's the part that you most definitely would need your calculator on, because you're talking about 1.025, times itself,
right,
4 times. So that part, that's the most part. For the most part, that's when your calculator really steps in for the exponential piece. Okay. And so 1.025 raised to the 4th power. And then even in this next step as well, talking about 1.1038, at 1.312, so run on decimal. And then you want to multiply that times 4,400. And that's how we get our answer.
All right. Mm-hmm. All right, so can you scroll back up real quick so I can see the problem? So that in 1 plus the 0.10, so 10 cents divided by 4.
Mm-hmm.
That's a division. So that, yes, because that line means division.
Mm-hmm. Matter of fact, in the calculator, it would be seen this way. And it'll be a slash like that. At least in your calculator, anyway.
All right, how do we? No, never mind. That's a calculated question. I was say how do we input this into a calculator? This.
Now for your thing, you would do it just like that. Now I don't know if you can see mine. I got an 89. But you'll have a parentheses. You can just hit them.
If you have a fraction or a division problem inside of it. Oh, so if it's a fraction or a division, it's going to be written the same in the calculator? Yes.
You got a division button, like in this 89, I think yours is the same as right above the multiplication symbol. It's just the division. So that symbol right there is the same thing as a fraction.
Okay.
Yep. So 5 over 4 is the same thing as 5 divided by 4.
Okay.
All right. Anything else? Anybody else? Everybody good? Everybody straight? So, like I said, I'm not going to do anything new today. Try to give you guys a little bit of a breather. As far as new material is concerned, next class we will be looking to get into chapter 4, which is our next chapter. I know it skips around a little bit. We did 2, 3, then we jumped to 10, and then we're going to 4. But that's how they got it set up. We'll be all right. So we'll look at chapter 4, start chapter 4 when we get back next class. Also there'll probably be room for questions then as well. So yeah. Anything else? Anybody else? I don't make anybody feel like I'm rushing anybody off. Is everybody good to go?
I got some more questions.
So chapter 1 test is due. The first test 1 is due Sunday, right?
And the homework. Don't forget the homework.
Okay, and the homework. Okay.
All of chapter 1's content. All right, Mr. Tucker, you say you had something?
Yes, and I keep getting confused on these questions about natural numbers, whole numbers, integers, rational numbers, real numbers, irrational, all that stuff.
Mhm.
I get confused a lot because it tells you, like, the questions say, like, name all of the numbers. Is every number is a real number, right?
Every number is a real number. Yes.
Every fraction is a real number.
Yes.
Every negative is a real number.
Mm-hmm.
What is an integer? Any number that can be written as a fraction?
Well, an integer, okay, let's go to the beginning. Natural numbers start with 1 and go on
So
to
not
positive,
0.
not 0.
So
So think about hole as like a hole in the ground. That starts with 0. So let that 0 be like a hole. I don't know if that helps or not,
okay.
but that starts at 0. But it's all your natural numbers and 0. Now your integers includes all of your natural and whole numbers and then negative numbers. But notice we haven't talked about any fractions or decimals yet. So no fractions or decimals when it comes to the first 3 categories. All right. So straight on those first 3.
Yep.
All right. So now, when you talk about rational numbers, let me see, I'll call those integers. When you talk about rational, those are all your natural numbers, whole numbers, integers, but then anything you can write as, well, let me say it like this. Repeated decimals and terminal decimals. In other words, terminal means end. So in other words, your decimal has an end. So if it's a repeated decimal, like 1/3 repeats 0.333 repeated, so that will be considered rational. 0.25 is the same thing as 1/4. So that's considered rational. It has an end to the decimal. So even if you don't, because every fraction is a decimal, you know what I mean? Those are the same thing. So if you want to look at your fractions in terms of decimals, if it repeats or is it into the decimal, it's considered rational. And then irrational, everything else. Non-repeating.
What's a non-repeating decimal?
I'm about to show you. Give me one. Let me write this thing right. Non-repeating, and that's not how you spell repeat, but
I don't care about the spelling. I ain't judging at all, brother.
Yeah, I appreciate it. Let me see. Non-repeating, non-terminal decimal. So when you look at the square root of 2, what's my square root? There we go. Square root of 2. I just want to be a little accurate. Yeah, 1.414213, blah, 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 blah. Like it's not repeating and it has no end. That's irrational.
It's not repeating and it has no end?
Right. Right. So if it's non-repeating, non-term, because remember, if it has an end, then it's up here as a rational. You see what I mean? So let's say if something was 5454 and it ended right there, decimal, 0.5454, then that's rational because it's terminal. It has an end. So,
but that's not repeating,
huh?
Because but that's not repeating. 5454 is not.
But remember the first dictation on whether it's rational or not is it's terminal. So if it has an end, then it's considered rational.
Okay.
If your decimal ends, it's considered rational. But if it does not end, then it's irrational. Once again, though, if it repeats, though, it's rational. You see what I mean? So those are the 2 types of decimals you're looking for. If it repeats or if it's terminal, then it's considered a rational number. Somebody over here. Yeah, I saw that. And then pi is what, 3.14159 to infinity. So pi is irrational. So any number, once again, if it's a decimal that does not end, does not repeat, is considered irrational. Those are the only things that fit there. So your best bet might be to convert, your stuff to decimals and compare it that way. Throw it in the calculator, convert it to a decimal. Square root of 5 is another one. Talking about that's 2.23606. It just goes on to infinity and is not repeating. So that's irrational. So be careful. Don't take the idea that because you see a square root, then it's irrational. Because if you had the square root of 121, that's 11. So that's rational because it ends. It's an actual energy. All right.
All right. Is there any example of a number that's not a real number?
You guys won't experience that.
Okay.
That occurs with imaginary numbers, taking the square root of negative numbers and everything. So you guys won't experience that.
Okay, so it's fair to say that in every question that asks me what kind of number, put this group, I can press real number and that'll be one of the right answers.
Yes, all of them should be real numbers. Yep.
100%. You got it.
Yep. So also somebody asked about sending a scratch paper. Yep, you can just shoot it to me in an email. Somebody answered it. Thank you for that. Yep, you can shoot it to me in an email, regular email.
Is that right? I was trying to make sure I saw the right answer. Is that right? Because I read it and I was like, you can email or send you a picture.
Yep, you're fine. Yep. So you just take a picture. You can take a picture with your phone. If you want to scan it, you can scan it. It's up to you how you want to do it, but you can just shoot it to me in an email. All right, cool. Just vtucker@tcc.edu. All right. What else we got?
And I scribbled a couple of choice words on my scratch work while I was frustrated doing these problems.
No judgment, sir. No judgment.
All right. I just want to let you know.
Right. I'm not passing it to anybody else. It's just me, so you're good.
Understood.
All right. Anything else? Anybody else before we close out? Make sure we're all right. All right. So if any other questions come up over the weekend, feel free to ask them next class. I'm not gonna, I don't plan on spending the whole lecture, talking. So, we'll have time. If not, shoot me that email. We'll make it happen. All right. So we good to close? Everybody good?
Yeah. So when can I get with you to talk about the calculator and how to use the calculator?
When the next time you're free?
I can make myself available. I own my own company, so I can make myself available whenever.
Tomorrow, so you say you're free tomorrow? Is that too quick?
No, that tomorrow's Friday. Yeah, I can make myself available tomorrow for sure.
Okay, shoot me that email, and because I'm pretty free on Friday, this Friday. So
AM or PM?
I mean, we can do AM, get it out the way.
All
right, so we can isolate the time. Yeah, shoot me that email and we'll make it happen.
What's too early for you?
Well, I got to make sure these kids get into the school. So, and I got to take my son to the school at 9. So around 10, or is that too late for you as far as what you're trying to do?
No, I'll make that happen. 10 o'clock. I'll shoot your email. Do we meet at the school or something?
No, we can do it through here. Yeah.
Okay,
we'll talk it through because, like I said, I got a very similar calculator right here. So yeah, we'll be able to talk.
Do we just do like a Zoom? Are you gonna send me a link to a Zoom or something?
Yeah, I'll send you another link.
Okay. All right. Cool. I appreciate you.
Not a problem.
Thank you very much.
Yes, sir. All right, everybody, have a good one. Have a great weekend, and I'll see you next class.
You do the same, man. Be safe out here.
Thanks. Do the same.